Hello, Kevin Vandekar here. Welcome back for the last module in the 3ds Max SDK training. Congratulations for getting through all of the modules. I hope that this has been an enjoyable class as well as educational and has given you a good introduction and a good basis to get started with the SDK. The SDK is a huge thing. So, as you've probably already seen, there's many different complicated systems, and there's lots of places where the system is error prone. So if you're not on top of your plugin, you could have crashes lurking, bugs lurking, etc. So that's what leads us into this final day's presentation to talk about debugging and just to give you, make sure you're aware of how to use the tools, all the tools at your disposal, and things that you can do to help get through any problems that you're having. So first thing I should do is go over the exercise from yesterday. Okay, so I'm going to switch over and take a look at 3ds Max first. So let's just review what the material was supposed to do. So I've got the material editor open, and I've just clicked standard, and here's my exercise 9 material. Discard the old material. And first thing to notice is that these buttons are actually being created by the parameter block. So that's a very nice feature of the parameter block system, is that you can tie your material to the user interface as well as to the parameter system itself, and it creates the UI. So the material type button will open the material in map browser. So I can pick my material, and let's pick the second one. So in this case I'll pick a standard material, and then the idea was to take those two materials and mix them together and use this spinner to perform the mixing amount. Okay, so to take a look at the code, here we are in Visual Studio. So I recommended that you consider restructuring the material, and so one thing that I did was right off the bat I got rid of the array for handling the material, the submaterials. So if you remember back from the reference system, one of the the advices from 3ds Max engineering team was try to avoid using arrays in the reference system. And so when you looked at the skeleton code, you probably noticed that array is storing the materials, but it's also working on it as a reference maker. So we're making references to those materials so we can keep track of them as we go forward. So that kind of violates that idea. And so in this case, the assignment was to create ask for two materials and then mix them together to create the final material. So we know we need two materials, so why not just restructure the code so it's easier to read, easier to manage. We're not using the array, which can get us into trouble, and things are just much easier. So I guess the point here is that, yes, the plugin wizard is great at getting you started, but also know that the wizard generated code may not be the absolute ideal implementation for your specific needs. So in this case, take a step back. We're going to throw that array out, and we're going to restructure the parameters in a way that we can keep track of them very clearly. So I commented out the number of submaterials, and what I did was I created defines for the specific reference IDs. Okay, so this is the index into the references that we're going to keep track of. So my parameter block is going to be 0, the submaterial is going to be 1, and then the material that I'm going to use to mix is going to be 2. And then I got rid of the array completely, so I have two materials that are member variables of my material class. You can see that it is derived off MTL, which is one of the primary material classes. And so now I have a much cleaner start to implement my code. I also changed the name of the spinner to be mix amount, and I changed this from being an array as well because this was a parallel array with the material array. So now I have just a single instance of everything I want to keep track of. So we look at some of the implementation details. So the number of submaterials, well, I know I'm going to have 2, or that I can work with 2, and so that can be made to be specifically 2. So we're no longer dealing with that define of a variable number of things, or even a static number but needed to be changed up here. So it's very clear now we're going to have 2 materials, and the subtext maps remains unsupported in this material, so we're returning 0, so you didn't really have to do anything there. And then the number of subs, I'm returning 3 because I have 3 sub-animatables now. So I have the parameter block and the 2 materials. And the same is true for the references themselves. I have 3 total, 1 parameter block and 2 materials. Okay. So let's take a look at the implementation. So first of all, I restructured the enumeration to match my parameters more clearly with names. In the parameter block descriptor, you probably noticed that there's some different types now. So first of all, we have this material button, and that's what I talked about in the user interface. There are a number of different material handler buttons, as well as other UI elements. So for example, you can see there's a pick node button as well. So in this case, we're using the material button, but there's also text map and bitmap and so forth. So just by specifying this and assigning it to a button control, it gives us that behavior linked to the parameter from the user interface. So that button launches the material browser, for example, and allows you to choose something and brings that material back to your plugin as a parameter. Okay, so a very nice tie to the UI from the parameter block system. Also note we've got a tie to the reference of the material as well. So now we're tying this parameter to our instance of the material as a reference. Okay, so it takes a reference number, and then there's also the submaterial number. So in this case, you can see my submaterial reference is 1, and then the submaterial number is 0. Okay, so they're a little bit different in terms of their identification, but also very nice feature to tie your parameters to your referencing and your submaterials in this case. So the implementation, we go into the constructor, and you'll see that we need to null things out. We set up reset to delete the references, so when the material is reset, we clean up our references. We didn't need to do anything with the parameter dialog because we're using the built-in things. Validity we needed to update so that both our submaterial and our mixing material are included in the validity, and you can see what's happening here is the validity starts at forever, and then we intersect that with the validity of everything else. And also note that when you call a get value on a parameter block with the validity, the intersection is done internally. So whatever you pass in is used to intersect with what its validity is, and is passed back to you. Okay, so that completes our validity. So up here we have to kind of do it manually, and with the parameter block, the get value handles that for us. Also, let's take a look at get reference and set reference. So here you can see I cleaned this up to very clearly use the references that I'm holding on to. So the submaterial reference, return submaterial, the mix material reference, return the mix material. Okay, and then the parameter block was 0, so that would be the only other one. Same with the set reference, I'm setting them up. The sub-anim name is important here in that we now also need to track our sub-animatables. So it's very similar to the get reference and the set reference. Okay. And then the notify ref changed. We really didn't have to do anything here because note that it's handling the parameter block as a whole. So it goes to the parameter block, looks for things that have changed, and invalidates the UI based on anything that was changed. The get submaterial is slightly different because we're using only 2 materials. We have 3 references, but we are only using 2 materials, so we have to use the indexing appropriate here. So since there's only 2, it's going to call me with 0 and 1, and I need to return the right material as well. Okay. Set material is using replace reference, so what we can do is we can use the index, and this should only be called on our 2 materials. So we just add 1 to get the submaterial, and we can add 2 to get the mixed material. So what I'm saying is the index is going to be either 0 or 1, and then we just add 1 to it to get our actual index. Okay, so that takes care of the texture maps. Remember, we did not implement any of those. And the save and load we didn't have to really touch because we're using default things and they're part of the parameter blocks, so those get filed automatically. Clone, you didn't have to implement this, and in this case I just commented the whole thing out, so this material cannot be copied. But if you needed that behavior, you would have to implement all of this, and there was a good starting point. But again, you know, it had this array goo, so you should have probably, if you implemented this, cleaned that up. Notify dependent, notify change. We didn't have to change anything there. We do want to handle update, and again, this is a validity interval thing. So we basically do something similar where we're updating our interval, and then we return the result. The colors here, we didn't really have to change anything. I did update it to support just my 1 material instead of the array. And then finally we have the shade, which is where most of the work is done. So first of all, note that we have a shade context being passed into us. Okay, so the first thing we can do is we can use that shade context to display things, to update what the material is going to look like. So in this case, because we want to mix 2, what we can do is we can first of all create a temporary version of the shade output. Now notice in the shade context, it has a version of this. So the shade context out member is a shade output. And the way this works is whenever you take a material and you shade it, so I'm taking my submaterial and calling shade on it, the shade context out is updated with results. Alright, so this one being passed in is updated, and what I can do is I can store that output in a temporary variable. Okay, so I'm just basically caching it at this point. And then when I want to mix them together, what I can do is shade the other material. So I'm going to shade the submaterial, which is the primary one at this point, and that updates the shade context again. So then I can use that output, which is the results of the submaterial, and I can mix it with the results that I've stored in this temporary version. Okay, so you can see I'm passing that in. And then the result ultimately of the output is going to be the mixture of the submaterial with the mixed material, and it's going to be mixed in the amount of my member variable mix amount. Okay, so I think the materials are fairly complex, but I think this gives you a good starting point for understanding materials. Of course, if you look at the samples, these routines that actually provide the output are very complex in many cases. So if you want to have a very sophisticated material, a procedural material, something like that, the algorithms are going to be heavy in here. So also note that this material is functioning, but it's not absolutely complete. So it's a good starting point, and as with all of the exercises that we've gone through in the class, they're meant in specifically to introduce you to key concepts for each plugin type and each part of the SDK that we looked at. But just know that none of the exercises are really complete. We didn't do a lot of error checking. We didn't implement things that weren't related to the topic we were covering. So all the exercises were meant to do was to introduce you to key concepts and get you thinking about that part of the SDK. So as always, do error checking, and our next topic is going to be on debugging, and so that can also help you to get clean and well-formed plugins. Okay, so let's take a look at the presentation for today. We're going to mainly be talking about debugging concepts with the 3ds Max SDK. But before we get started, I'd also like to just kind of summarize the class. So the agenda that we went through was this list. There were a couple of big topics, for example, the geometry and geometry pipelines. Those are really big topics, and so we went kind of fast through those things. Also, animation is another big one, and then the lights, cameras, materials, and texture maps. So I apologize for going kind of fast through those topics, but I also wanted to kind of touch on all the major areas of the SDK. So, please let us know if, the training was good. We'll be sending out a survey, so I hope that you'll take the time to fill that out. And also, if there's anything that you would like to have more details on in the future, if we get enough requests, then we can probably do some specialized webcasts like this, but on more advanced or specialized topics. So again, thanks a lot for your attendance and your great questions, and I hope it was an enjoyable class. Just a quick word about the exercises. Again, just remember that the exercises are not complete. They're just meant to show key concepts and get you started in working in the SDK and seeing how the code is structured. They have little or no error checking, so I really discourage you from putting any of the samples or the exercises as is into production environments. Even with some minor changes, I would just encourage you to really take the time to test and test and test and make sure you feel good about the code that you're going to be using in a production environment. Today's presentation then is on 3ds Max SDK debugging, and the goal here is to I'll do a little bit of philosophy on debugging practices. We'll talk about 3ds Max specific output routines. I'll do a quick introduction to the debugger and its tools. We'll take a look at how you can use symbols, and also a quick introduction to how the customer error reports work. So first of all, a little philosophy. So debugging is fundamentally problem solving. And I like this quote from Albert Einstein, which is, "Intellectuals solve problems, geniuses prevent them." So the point I take away from that is you should try and be a genius when you're coding. Because if you can prevent the problems from happening in the first place, it's going to just save you a huge amount of effort later. So what is debugging? So when you look at the Wikipedia definition, there's this definition here, and this last statement is something that struck me as interesting. Debugging tends to be harder when various subsystems are tightly coupled, as changes in one may cause bugs to emerge in another. So this concept of tightly coupled really refers directly to a plugin developer. So working with 3ds Max, you're a plugin, and because you're a DLL, you are very tightly coupled to the 3ds Max.exe, of course. And so changes in Max may cause bugs in your product. Changes in your product may cause bugs in Max. So you need to keep this in mind that you are running in the same process space, and just be aware that Max changes from release to release. So to go a little bit further, for the coder, it's much easier to understand at implementation time. So when you create your code time testing is really important. So this is often known as unit testing. So unit test your code as you're writing it because you understand it at that point in time. Okay, especially if you have a complex algorithm, maybe function publish it as a Max script and write some unit tests so that you could script it and run it from release to release to make sure you're still getting the same results. something pretty easy to do at the time that you're writing the code. And of course, document your code. It's very, very important, even to yourself. If you're a one-man operation, even 3 months down the road, I'll bet you can't explain a complex algorithm that you wrote. So write it for your own benefit, but if you're in a larger company, write it for everyone's benefit. Okay? So document especially anything that took you a fair amount of time to work out and understand. It's just really helpful to yourself and to other people. So oftentimes when code is written, it works fine, and then 3ds Max changes versions, and then someone has to come back and debug a problem. So when you're the inspector or the debugger, it's much, much harder. So you're probably debugging other people's code, but if it's your own code, it could be from your distant past. So it just is really, really challenging as time goes on. So it reinforces item number 1. Just try and make everyone's life easier by unit testing and documenting your code. So how to debug? So the very first step is to verify the problem and reproduce it. Okay? This is just so important. There's no use setting breakpoints, stepping through code, etc. without knowing how to reproduce it. It really helps to document those steps so that if you're distracted for the rest of the afternoon, you have to go pick it up the next day, you can remember, oh, these are the things that I've tried, and this is where I'm at. And then also try to narrow it down to as small of sample as possible, so that whatever it takes to reproduce it, just make that set of instructions very small. So, I've been in our software engineering team in the past, so I've worked on Revit and AutoCAD, so I have quite a bit of engineering experience, and I've seen so many developers that will get a bug from a customer, and it's got good reproduction steps, but the first thing they say is, oh, I know right where that is, and they'll set a breakpoint, and they'll run to it and change the code. Well, now all of a sudden you've changed the instance and behavior, and if you weren't right, now you've complicated your problem even more. So very first thing is, especially if you get a bug from one of your customers or one of your artists or someone working in your organization that's using your code, take the time to sit down and try and reproduce it based on what they say, and then go into your code base to see if you can sort it out. And then when you're working with Autodesk, again, it's important to have as small a reproducible sample code as possible. So if you're reporting a bug or you've seen some change in behavior, something like that, and you've got a way to reproduce it, boy, that just helps us go a long way to being able to help you more quickly. If you just ask an open-ended question, we may not be able to help you at all, and that may cost us a day or two of time before we actually get something that's useful. So, of course, then once you have found the problem and you've narrowed it down, then you can find the entry point into the necessary code branch. Now, if you have a very large code base, multiple materials, multiple modifiers, something like that, one of the things that can help you is to use the UI resource strings. So that's especially if you've got a set of instructions from the user that say, click this button, and then when I click this button, it blows up. You can kind of find those UI strings in your resources and then search your code base for where those are, and that's going to get you very close to where the problem resides. Okay, so let's talk about how to actually do the debugging. Okay, there are some different techniques. So first of all, there's coding techniques. There's application-specific options. So these are basically things that the application provides to help you to debug. You can visually inspect the code directly. You can use the Visual Studio debugging tools, of course, and that's the bulk of your debugging capability. And then Autodesk also has this thing called the Customer Error Report, which provides a mini dump. And I'm going to show you a technique that can be useful for you to use those files as well. So first of all, coding techniques. So the simplest form is to use output statements. So there's debugger output, such as output debug string. There's application output, so you can just do things like printf or the standard C++ cout. There's all kinds of output routines you can write to a file, that sort of thing. And then 3ds Max has some specific output routines as well, like Max message box. There's a Max script facility that you can use in the SDK that will it's called mprintf, and it will print text to the Max script window. And then as far as the debugger tools go, if you look at the Microsoft documentation at this link here, there's a whole list of things that you can use in debug context. Okay, so these are specifically debugging type functions. So for example, you could do a debug break within your code. Okay, so these are things that might be helpful if you're in a really difficult piece of your code. Here's the output debug string, which is this one here. Okay, and these are specific to Microsoft's compiler. Okay, so let's just take a quick look at some examples here. So I've got 3ds Max running, and I'm running this modifier type plugin, and I've got some output statements. So first of all, this first one is the generic Microsoft specific output. It's called output debug string, and depending on where you are down here, you might have to switch to it, but there's an output window here. And Max itself puts a lot of output in here as well. You can see plugin loading, for example, etc. One of the things that you can do is you can turn off some of those messages. Okay, so you can turn on and off in the output window. And program output is specifically what is related to this API. Okay, so let me just run over that. And here you can see output debug string, and I'm getting a value. Okay. So we also have the Max specific one. So if I go to definition, you're going to see this is in the 3ds Max SDK. Okay, this is something that's specific to Max. And if I step over that, you're going to see it also outputs to the output window. So this is a Max specific API that allows you to also put strings to the output. Okay, so this kind of gives you an application specific way of getting content to the output window. There's also this Max message box, and so this will pop up a dialog box basically, and that's a convenient way to get some data, and it also stops the execution of the program, so you wouldn't necessarily need to have a breakpoint here to see the message and stop your program at that point in time. So this can be convenient to help you debug on a user's machine, perhaps. So you might insert this in, give them a special build. When the dialog pops up, have them give you the contents of something you write to it, and then you can know kind of the state that they were in when they ran into this. Okay. And then the next one is Max script output. Okay, so let's just step over this. You should, you basically formulate a string, you push it through mprintf, and then you should flush the buffer when you're done. Okay, so when that's done, let me just run to the end here. You're going to see the text is actually printed in the Max script window. So that can also be handy, especially if you've done function publishing and you're kind of used to working in the Max script window. You can get some text feedback. It's also useful if you want to give some messages to the users that might be part of your function publishing. So some other coding techniques, something that's commonly used is the assert. So this is something that ensures code safety, basically ensures conditions are always met, and it's definitely useful during the dev cycle and any of the testing. So One of the ways we use it is in combination with preprocessor statements. So you can basically put your asserts within some custom preprocessor name, and then what you can do is after you've done all your testing and all that kind of stuff, you can turn these asserts off easily just by undefining the preprocessor statement in your final output. So we do this for our production code even. So we have asserts turned on typically during the dev cycle, and when things are being tested, the asserts actually come back and give specific information. So someone who's in quality assurance can see the assert. The asserts will provide line numbers from the specific module and the CPP file, and then the tester can actually report a defect and put all that information in, and then from a developer standpoint, they only need to look at that specific line number, set a breakpoint, and run the repo steps and reproduce it. So very useful technique. So asserts by themselves are good, but I would encourage you to think about using preprocessor statements around your asserts so that you can turn them on and off and make them be on as much as possible except when you finally release. So 3ds Max specific options, so you can actually create routines that work in MaxScript context. So that would be function publishing. We've already talked a lot about that. There is, if you're an ADN member, there is a full debug build with symbols that has also some base source code. And so of course this is the most flexible. It's kind of complex to get it set up and ready to go, but this is a full debug, so you can actually use the full debug runtime libraries and all of that, and you can debug. We make it available only to ADN members, but it is talked about in the documentation, so it's nothing that we hide or anything. So if you are an ADN member, you can get this debug build. Now, it's something that the engineering team has to put together, and it takes a lot of extra work from them to provide it to us. So at the moment, we're a little bit behind, and we don't have it ready for 2013. It is available for 2012, though. But the next best thing, if you're not an ADN member, is the public symbol server. So this provides the PDBs, the symbols, on a public symbol server, and then you can basically specify the location in the debug options, and then the symbols will load, and you can at least get call stack information. So it's a much more detailed call stack to see how possibly a routine in your plugin is crashing, or possibly how your plugin is crashing a routine in 3ds Max, and it might give you a clue as to what's causing the problem. So I would encourage you to take a look at the public symbol server. And for 2013, that's all we have available right now. This next idea is to visually inspect the source code. So typically the source control tools have differencing tools. And so what you can do is you can very easily look at differences between old and new versions of source code. And then you can also look at the file history to see if someone changed that, and you can actually go and find out who made the change and ask them why. So with source control tools, most source systems provide the name of the person checking in and checking out, the versions, it maintains versions. So in this particular example, we actually use Perforce, and there's version 1 and version 2, and you can see in this particular piece of code they changed how some things work. So first of all, they renamed some arguments that were badly spelled, but they also changed this logic here. If length equals 0, they do this. But really what they wanted to do in the fixed version is the absolute value of length is less than epsilon, then they do the swap. Okay, so it may seem minor, but when you look at it from a differencing standpoint, these things stand out really quickly and really easily, and you can look at things. So particularly in the case where you might be using asserts. It gives you a line number of something that changed in your source code. You can bring it up and see, okay, this is the line, but I didn't make that change, or I haven't worked in this area for a while. So why is this assert firing now? So then you can go to your source control system, bring open that module, and you can review all the changes to that module that have happened, and it's probably going to give you a clue as to why all of a sudden you're seeing a new assert fire. Okay? And then even if you don't have a source control system, you can use other differencing tools. And what I've seen people do is basically just maintain snapshots. So if you have a pretty small code base, maybe a single plugin doing something, what you might get in the habit of doing is before you make a change to a working version, or before you port it to the next version of 3ds Max, make a copy of the source code and archive it somewhere. And then in your new copy, make your changes and continue doing that over time. And then as something breaks, you can at least difference back through your code to see what you've changed over time. So probably an obvious thing, but just in case, make sure you have a way to do differencing. And then that leads us to the Visual Studio debugging tools. So first of all, 2012 version of 3ds Max and also 2011 use the Visual Studio 2008 compiler, which is Visual C++ 9. Okay, so if you're working with 2012, you can certainly use Visual Studio 2008, but you've probably noticed that the SDK samples are in the Visual Studio 2010 format, the project format. So within 2010's build system, there's a way that you can target prior compilers. So this is going to be great going forward. So what you can do is you can target tool sets, but use the same IDEs or the newer IDEs as you go forward. So your projects target a specific tool set, and then you can move forward. So we're currently at Visual Studio 2010, and already I see that there's betas for newer versions. I think they're targeting it as Visual Studio 2012. So we're not there yet, but this idea of the tool set is going to make it easier to be able to use the future IDEs, but maintain the compiler support for the current versions that match the applications you're working with. And of course, the IDEs are very similar for debugging. Also, Visual Studio has these global debugger settings, and we'll take a look at those in a minute. And one of these things is the ability to turn on global exceptions. Okay, so let's take a look at that. Switch over to Visual Studio. So there's two ways of getting to the global settings. So under Tools, Options, you'll get this menu, and there is a debugging section right here. Okay, you can also go to the Debug menu, if I can get it to pop up. This new WPF-based system doesn't work as fast as the old one. So you can go to the Debug menu, and then you can go Options and Settings, and it's the same dialog, they just put you in the context of the debugging settings. Okay, so there's quite a few options here, and most of the defaults are fine. There's really no need to go and change these things when working with different projects from 3ds Max. Okay, some of these things might help you depending on the context. So for example, warn if no symbols on launch. So if you're relying on the 3ds Max symbol server and you turn this on, it's going to give you a warning before it actually starts up and chugs through saying it can't find all the symbols. So that's a useful one. And there are some other ones in here as well. Edit and continues. So this is a global setting. So if this box is off, it does not matter what your project-specific settings are set to. So let's go to the project settings here, and if we go to this, General, this is the edit and continue for the project. So even if this is enabled, and over here this is disabled, it's not going to work. Okay, and there's some other settings here that allow you to configure how edit and continue works. Just in time, this is not in the context of 3ds Max at all, but just to give you a quick explanation, any of these boxes that are checked, if you're running somebody else's application, let's say, Internet Explorer or somebody else's managed program, and this is turned on and they crash, just-in-time debugging will kick in, and if you have these checked, you'll see a dialog box come up and say, which debugger do you want to use, especially if you have multiple compilers installed. So you can disable all of that by changing this at the global level. There's some native options here. There's some configuration with how to work with the output windows. So remember when I right-clicked over in this area to show what's on and off, this is instance of the debugger running, whereas the settings over here will handle the defaults, which things are on and off. Okay, and then this is the symbol area. Okay, so if you want to use the Autodesk public symbol server, we have symbols for both 3ds Max and AutoCAD. Those are the only two products that are supported at the moment. You basically just make a new entry and you enter this web address. And what will happen is anytime you start up and this is enabled, it's going to take the symbols and cache them in this directory, okay, wherever you point that to. And then each consecutive time you start up Max, for example, it's going to load those symbols from a local location. Okay, it also typically will only load the modules as they're needed, so it's not going to load all symbols at the first chance. Okay, and you can also refresh your symbol cache by emptying it here. So I would encourage you to think about using this, but make sure that you don't get in the habit of leaving it on all the time, because it can really negatively impact the startup time. Because for each module, it will try and load the symbol, so there's a file I/O operation, first of all, to get the symbol loaded, and then loading the symbol itself into memory also takes some time to map the symbol to the actual source code if it can, and that would apply mainly to your own source code. So that's up to you. We strip our symbols so there's no source code information in our symbols on the public server. All right. Okay, so that leads us to the project settings. So let's just take a look at those settings here. So I go to the debug demo. This is my project name, and I click properties. And there's all of the different property configurations, and there's the debugging tab or page. So you can see that for debugging, I'm pointing to 3dsmax.exe because that's how the DLL gets loaded. You can specify command arguments, and you can see here in this example I specified a scene file. The working directory is typically default to the project directory, but you can specify that anywhere you want. Attach has to do with whether the debugger should attempt to attach to an existing project or an existing process. So typically we don't use this unless you have a real specific need. Normally you would specify the command, and then this would be no. Debugger type is interesting in that you can specify what types of applications to debug. So when you have it set to auto, for example, when the debugger starts up, it's only going to run in the context of the process that's starting up. Okay? So in the case of auto, because you're starting up 3dsmax.exe and it is inherently a native mode application, it's only going to allow you to debug native code. Okay? If you want to debug managed, then you should change it to managed only. You can also specify native only. And then the one that's the most interesting is mixed. So if, for example, you're using C++ CLI, which is a way to create a plugin that's using both native C++ code mixed with managed C++ CLI, then you should set this to mixed, and that's going to tell the debugger that it can debug through both. And even in that context, there might be reason to say, well, I only want to debug the managed portions or the native portions. Okay, and auto is usually the default here. So if you're working in both environments, you probably want to get in the habit of changing that to mixed. All right, and the other interesting thing about project settings would be back over here on general, and you can change the program database to be edit and continue. And what that does is, working in the context of the x86 version of 3ds Max, you can basically recompile portions of your code under runtime parameters. So you have to first of all have a breakpoint. When you hit that breakpoint, you can change the code that follows, and then what will happen is it will recompile in memory and allow you to execute it. And it really depends on the context you're in. You can't add methods, for example. You can't do complex operations, but you could change an output routine. You could change a variable to be assigned to something else, that sort of thing. Okay, so let's take a look at the Visual Studio Debugger and the tools that you can use there. So first I'm going to look at the watch window. And so this is used for watching variables as the program executes. So there's 3 different windows: autos, locals, and the watch window. And one of the interesting things that you can do here, which not everyone knows, is that you can actually change variable data at runtime. And then there's also the idea of using format specifiers to change the display of data. So if you have a very complex data type, you can actually configure a specifier, a format specifier, that will output the data in something more friendly for you to use during debugging. So let's just take a quick look. So I've got my debug demo running here, and I had a breakpoint here, and I've just stepped over. And you can see I've got, for example, a variable here called t. So one of the things you can do is you can click in the window and you can actually change that variable. And it will change it to red to show that it was changed, but it also shows that it accepted the change. And now t is 25 in this case. Okay, so that's a very cool thing that not everyone knows, and it helps you to do testing. So you're debugging through and you see that, oh, it doesn't work with 10, but what if I bump it down by 9? Maybe I got an index out of range, and see if it gives me a value at 9. And so you can at runtime change that. The other 2 windows are the autos, and this is basically the variables that are in the context of the runtime. So wherever you're at, I think it gives you like the 3 behind and 3 forward. And then there's also locals, which in theory is supposed to be everything that's in context, even uninitialized things. Okay, so you can see that I've got some things there. But you can see that t is reflected as 25 as I changed it. So the next topic is about breakpoints, and so you can basically set one by pressing F9, which is the typical keyboard commands. Of course, keyboards can be remapped, so it's however you have it set up. You can also right-click and set breakpoint, or you can click in the margin. And of course, it halts execution in a specific line, and this is one of the most powerful things, so I'm sure you already know about it. So it allows visualization of memory state at a given execution state. So with breakpoints, as you're executing, there's also this context where it allows you to step into, step over, step out, run, and run to cursor. So this is the runtime context. So if we switch over here as well, so a breakpoint looks like this, and that's where it's going to stop. But there's also the execution pointer. Okay, and so this is where the current line is being executed, and as you step, you're getting different values. Now, another interesting thing you can do here is you can actually say, okay, I don't want % to be calculated. So you can grab the execution pointer and you can drag it. So you can see that, let's see, % is currently garbage value. So let's go over here and let's put in %. Okay, so you see it's garbage. And if I was to run this, I'd get 40 divided by 100 as my result. Okay, but let's just drag this. So I've changed the execution pointer. It's going to go to the next available line. It can't execute that because that's a declaration. So it skips over it, and you can see it did not execute that. So it's a way for you at runtime while you're debugging to drag the content text and skip over code as you want. Okay, I also want to point out that there's some specific breakpoint types, and these are very handy when you're working with things like loops that are hitting a lot of iterations. So maybe the crash only occurs after 10,000 iterations, and this is particularly helpful when working with complex meshes or something like that where you have a lot of iterations going on. So what you can do is you can specify something like a hit count. So when it hits 9,999, stop, and then I can click through the 10,000 to see exactly where it's crashing. Okay, so very useful there. And there's also some other windows. We won't go into details, but just know, of course, there's the call stack window, the output window. So remember to use that right click to turn off output you don't want to see. There's also a way to redirect some output to the immediate window. The immediate window is something that Visual Basic uses a lot, but it's up to you. It's another output window basically. There's the modules window, which will show all the modules that are loaded in the process space. So that's useful to see maybe if your plugin got loaded or that kind of thing. There's the registers. That's pretty low level CPU registers. The processes, threads, and memory. So these last four probably aren't that interesting in the context of 3ds Max, but they can be very useful. Some tips and tricks, get in the habit of using the breakpoint window. Let me just switch over and show you this. So the breakpoint window over here is a very useful UI element. So not only can you label things, but you can toggle your breakpoints on or off, and you can see them in the order and the line number that they're on. I had a colleague who didn't even know that the breakpoint window existed. She was just working primarily with the dots over here. So this is just a very useful tool. With labels, it gives you can actually click and say edit labels, and you can change a name here. So let's put in a name, and you can see that label goes right in there. So you can, if you've got common code that you're hitting a lot and you have common breakpoints, it's really useful. And then disable rather than delete breakpoints. So disabling would be just toggling them on and off. So when you disable, they'll stay, but they just won't be active. So rather than removing them and then having to remember where you put a breakpoint, you can just turn them on and off. There is this notion of call stack breakpoint. So if you're getting a particular crash at the call stack location, you can actually insert a breakpoint at a call stack location. Use step into specific, and this is the ability to, when you're in a runtime context, you can right click, and then within the function you can say step into specific, and this will give you a list of the arguments if there's sub functions being passed as arguments. So a lot of times you'll say do this, and you might have 4 function calls that are returning values that you're passing as arguments, and with the step into specific you can step into those functions directly without having to step in and out, in and out. Run to cursor, I showed you that. Well, not really a run to cursor. So run to cursor is wherever your cursor is flashing, you can say run to cursor and it will run to that point. Okay. And then the next one is drag the execution pointer to another line, and that's what I showed by being able to just drag it down and it will skip whatever line it was on. Change values in the watch window, we looked at that. You can use the find tool in other windows as well. So if you're, let's say, looking for something in the output window, when you say find, if your cursor is in this, it will search this window rather than your source window. And then also make sure to remember to turn on or off output that might or might not be interesting. Okay, so that brings us into this customer error report topic. Okay, so let's talk about the CER report now. So it stands for the Customer Error Report, CER, and there's key information that's collected by CER. So this is, clearly something that Autodesk uses to figure out what customers are having problems with. So it includes what's called a mini dump file, which is a Microsoft DMP, which is a debug dump file, and it's basically a snapshot of the memory at the time that the crash occurred. It also includes applications counters, so it just kind of gives us some detailed information about the state of the application at the time that it crashed. So it also includes system information. So we have hardware information, which includes the computer manufacturer, RAM, number of processors, etc. Video cards, which is really useful especially for the M&E products, operating system, computer name. So how can this be useful to you? Well, the mini dump file is a file that's on your disk or on the user's disk when something crashes. So you can take this DMP file and you can debug it. So the first thing you need to do is make sure you have the exact production install indicated in the CER data. So if this crash happens on your machine, the CER report is going to match. Okay, but if you get this from a customer, make sure that you have whatever service packs they have installed, etc. And then also, if you want 3ds Max call stack information, make sure the symbols are working for you as well. So the first thing I would do is, in a basic module of some sort, start up 3ds Max, configure the debug symbol server, and make sure that the symbols are matching and working for you. And then the final thing is to run the Developer Studio environment, which is dev-env, and pass in the mini dump file name. And this will start up the debugger in a mini dump mode, and what it does is it basically replays this dump file. Alright, so let's take a look at how this can be useful. So I'm going to create a sphere over here in 3ds Max, and I've got a modifier that I've been demoing for this debug information. It's called debug demo, and I've configured some crash routines, and so I'm going to crash 3ds Max. Okay, so I get some data back. And here you can see there's an application error, and then 3ds Max has given me the CER report. So one of the things, if you view the report details, you're going to see that these files exist on your system. Okay, these are the files that are sent to 3ds Max. Alright, so what I typically do is, let's just cancel the dialog. I have a batch file that I run that will copy the data over, and it unzips the zip file. Okay, so the first thing you're going to notice is that there's an XML file, and this contains the data that's associated with the crash. So there's things like the computer name, user email value, the application. Here's the product version, so this is really important. Lots of different information. And this is also where things like the video card driver and all of that's going to be provided. So once you have that, then what you can do is you can debug that dump file. So you can see that there's a 3ds Max mini dump file located here. And what we can do is we can run the Developer Studio environment on that mini dump file. So let's go ahead and start it up. And the first thing it will do is it just simply loads that dump into memory. Okay? So before you hit debug, what you should do, and you can see this is kind of a special user interface. So this is showing you the dump summary, system information, the modules that were loaded at the time of the dump. And to debug, you would come over here and you would say debug, and probably debug with native only. But before you start debugging, you should also check your symbol paths. And you want to make sure that you have at least your own symbols on the path if you think it's a crash in your application. So you can see here I've got my path set up to the plugins directory of my production 3ds Max directory, and that basically says, okay, load the PDBs from that location. If you want the Max symbols as well, you should specify the Autodesk symbol server. Okay? And then as soon as you push the debug, it's going to start debugging that dump file. And what it does is it kind of plays it back, and this will take actually several minutes to get loaded. So I'm going to pause the recording, and then in the interest of time, I'll show you the results once it's finished. Okay, so we're back into Visual Studio. The mini dump has completely replayed, and I got to the break that caused the unhandled exception, which caused 3ds Max to crash and generate the SIR report. So you can see it looks very much like running a real runtime instance of 3ds Max. You can see exactly where the crash occurred. So if I hit break, what it did was, using my symbols of where my program, my module was actually built from, it was able to show me the exact line in which I got a crash. Okay? So the user experience was, bang, my program crashed and I got a SIR report, and it looks like, a problem. They may not even know that it's your program causing it. Okay? And this will generate a SIR report to Autodesk. But if you do know that it's your program, or it potentially could be your program, you could actually head this off and figure out how to, if there's a problem in your program. So in this case, let's see what happened. So I've got a null pointer. I tried to call the length on a point that has not been initialized. So it even goes down to the point of showing me the state of my data, of my variables within 3ds Max's plugin context. So it's a very, very useful feature in certain modes. So again, if you're having people using your plugins that are having crashes, you can see at least get a snapshot of where they might be. Okay, so that wraps it up. If you have any questions, go ahead and send me an email, and I can help you within the next few days. And I really appreciate your attendance, so thank you for coming to this class. And as I mentioned at the beginning of this session, we will be sending out a survey, so please give us your honest feedback. I would be particularly interested in knowing if you like the pre-recorded option. It does require that you log in a little early to get the downloaded content, but it sounds like it's working pretty well in terms of the quality of the playback. So let me know how you felt about that. And again, thank you very much, and we'll see you at the next webcast.